welcome back to On the Workbench. Today we're going to be looking at checking the refrigerant on this '08 Saab 97X SUV. I'm suspicious that it might be low because there's a weird whining sound that it makes when you start it up that I'm suspicious it has something to do with it being low. So it's one way to find out. The tools that you're going to need to tackle today's project are going to be as follows. First, you're going to need a good pair of safety glasses. You're going to make sure you want to protect your eyes because the refrigerant in our air conditioning system is a dangerous, hazardous chemical, and it is under pressure. And furthermore, since we're going to be working around a couple of the key pressure relief points to be able to access the system, we want to make sure we protect our eyeballs. We only get one pair of those. Make sure they last. Now, instead of clear, depending upon your setup, you may want to consider having a pair of amber safety goggles and a UV flashlight to be able to help you detect any other leaks in your system if you've ever had dye placed into your air conditioning system. Factory default does not include dye, but if you ever had air conditioning problems in the past, it's not uncommon that a tech may place dye into the system. Next, you're going to need a thermometer to be able to measure the ambient air temperature, because the readings that we're going to get off of our manifold set are also going to be relative to whatever the ambient air temperature is in the environment in which you're collecting this data. So you can either have a manual gauge like this. This is just a simple one from Robinair, or you can have a digital multimeter and then set it to degrees Fahrenheit or degrees Celsius as applicable to your specific chart and your gauge set to be able to know what the ambient temperature is to be able to get the appropriate relative readings. Next, you're going to also want a set of nitrile gloves to protect your hands. You do not want the refrigerant on your hand. First of all, it can be very cold, and you don't want to get frostbite on your hand or other freeze burn on your fingertips if it leaks out onto your finger, because you may have a little bit that leaks out when you actually go to connect your manifold gauge set to your quick connect ports. So make sure you protect your hands and you protect your eyes when you're working on this. Next, you're also going to need a pressure chart. You can, if you just Google the phrase R134A temperature pressure chart, you can find several variations that will show what the reading on your gauge set and relative to what the ambient temperature is in the air to know what those values should be. And then finally, the most obvious tool of them all is you're going to need a set of R134A air conditioning pressure gauge set. Now, there's a handful of different varieties of these that have different valve configurations. I've got a video all about this one. I'll put a card up in the corner here. This is one from Orion Motor Tech. It's worked well for me, and this is a 4-way valve, but they also make 3-way valve sets. So you're going to need to know how to open and close the various valves on your gauge set and in what sequence to be able to properly close down the system, so when you are collecting the pressure that the freon, I guess I shouldn't call it freon, I should call it refrigerant, is able to flow through your gauge set and back unimpeded and not accidentally releasing that refrigerant into the air. Because you do not want to release refrigerant into the air, it's important that you capture it and you understand how your specific gauge set works so that you don't accidentally have a release of refrigerant out of a port where you are not expecting it. And so overall, your tools are relatively simple. And now let's go over to the car and get started. We're going to be using our AC manifold gauges here. And the first thing we're going to do is make sure all of our valves are closed. I've got another video all about this specific gauge that I've got. I'll put a card up in the corner about that. There are 4 valves on this one. This is what's known as a 4-way valve because there are 4 valves on it. And so everything's going to be closed up on there. And then we're going to have our other ends that have our quick connects on it here. We're going to take these quick connects and we're going to connect them to the high and the low side. And so we've got a port here in front, and our other service port is right back here, both on the passenger side. And so now we just have to remove those caps and make the connections. We're going to set these aside to make sure that we don't lose these. These are important for keeping these connections clean. So then to start, we're going to take our blue low side connection and connect it back here. Making sure the valve is closed. That just kind of snaps right on. Takes a little bit of pressure to relieve that. And then we're going to take our high pressure one and we're going to connect this one here right in front. Let's turn the camera around so you can see that. making sure our valve is also closed. I'm going to use my hand underneath it as an extra bit of support. All right, now we got a connection on our high and our low side here, and all of our manifold gauges are closed. And so now, next thing we're going to do is check the ambient temperature reading for where we're at right now, just so that we've got some idea of what our ambient temperature is. So now using a temperature probe connected to my multimeter, you can see the ambient temperature is 72.4, 72.2 degrees. And so that's going to affect my R134A numbers that I'm going to need to be looking at. I'll refer you back to the previous video, and you may want to find a chart to make sure you know what at the various temperatures you're looking for your proper high and low side pressures. And now coming back over here, I'm going to open up the gauges here, or the connections here. Don't need to go out too far. Think of this as kind of screwing it down to depress the schrader valve. And then I'm going to come up to the meter and then open up the valve up here. So right now, with the engine off, we're getting readings of about 75 on both the high and the low. We're going to have to turn the engine on and see what that does and where our needles will move with the engine on. So then while I'm running the engine and letting it warm up, I'm going to move my multimeter over by the engine so I can get an appropriate reading of what the temperature is around the engine area when I know what to be looking for on my gauge cluster. Letting it run for a while on my gauge cluster, and after having revved the engine and brought up the temperature to open the thermostat all the way, it looks like on the low side my pressure has settled out at about 40 psi, and on the high side we're looking at about 155, 160. So I think we're right in spec based on the temperature out here. So I actually think I can run down and rule this out as a problem with my car. And so now with the temperatures there being correct, I feel good about just the health of my AC system. So I feel good about that. And then we will take the gauges apart and close it up and be done with this test.